I'm Anthony Pamart. I'm a CNRS engineer. I mainly work on 3D digitization, and I will present you the context of this study. So we are talking about the oculus. So it's the part at the transept intersection. So it's the part that has been greatly collapsed, and as you can see, I'm showing you the state of it was before the fire. So the structure of the presentation is the following. I'm gonna just firstly explain a little bit the context and the aim of this very specific survey. Then I'm gonna browse and interchange between in-lab and in-situ on-site parts of this experiment to show you and explain this context-oriented photogrammetric setup and workflow. So what happened exactly is that one day Livio texted me something like this and say, I have an impossible mission for you. I was like, okay, thank you. And I have very short time, and that's why I call it an emergency. It was not an emergency because it was just right after the fire. It was an emergency because the chronology was the following. So first, it collapsed. As Olivier explained, there were a really important part for clearance all the fragments on the ground. And then everything was made on inventory and a clear identification and a really interesting documentation process by photography. And then it was all put into a temporal storage on Barnums, which was on the forecourt of Notre-Dame on the Parvis. And before they were moving to the final archaeological deposit, all those fragments need to be depolluted because there were a lot of lead because of the roof. And the method that was proposed for the cleaning of those fragments may or will cause the loss of the remaining polychromic paintings. And as you saw on the pictures before, if we want to reconstruct even virtually those elements, of course, the polychromy is really important. So I was asked to go there for a twofold objective. The first one was to document the state for conservation purposes, because as I just said, probably all the polychromic elements will be lost within the next few days or few weeks. And then the idea was to digitize the still colored fragments to enable a virtual anastylosis in order to help the conservation and also the restoration purposes to understand the technical aspect of the construction. As I say, I was noticed quite short, so I have maybe one week to prepare, and my agenda just allowed me to prepare just for one day. So I went to the lab, and by chance, I have a more or less similar object in terms of size and complexity. And my goal was to design a fast and effective, quite massive digitization challenge. My main goal was to be cost efficient in terms of scanning. I don't have time to spend a lot of days on site taking pictures. I have to do something really fast and maybe not really precise, but at least fast. The colorimetric consistency was really important. If possible, to have something that was pre-cleaned, because as you know, it could be quite complicated to clean everything after, and we lose again time. And if possible, to reach automatic scaling and automatic registration by the sense that Livio asked me to have the complete fragments with both sides, and I wanted to do it completely automatically. So I made this setup, as you can see here, phase 1, phase A and phase B, and at the end we obtained this. All this was quite lightweight and transportable because, as you can see, all the photogrammetric setup was fitting in these bags. Even the square that you can see, we can unfold it, but it was pre-calibrated, so we done it for the return. The experimental result for this trial was quite interesting, because we just needed 30 pictures per face, so in total 60 pictures. We reached 15 million points in median density. We were more or less to millimeter range accuracy, which was really relevant for what we were planning to do. It was enough. The acquisition time was just around 5 minutes, and processing time 10 minutes. It means that in between 15 minutes we can have a coarse digitization of the fragments. Everything was compliant with batch processing, and at the end we obtained a dense cloud, scaled, oriented, and complete. Of course, when you go on site, you have to deal with a lot of issues and adaptation. But nevertheless, this protocol was quite optimal, because as I transpose it on site, it seems to be more or less okay. The complete setup is composed of DSLR, so just a classic photographic camera. We are using prime lens. Everything was mounted on slider to allow transition on translation on this slider, with an axis, three axis tilt head, in order to adapt everything if in case we have to adapt just the point of view to encompass better the object. We added radio synchronization with 2 flashlights crossing at 45 degrees with diffuser, in order to have diffuse and homogeneous lighting. Everything was stabilized with 3 tripods, 1 for the photo and 2 for at the extreme of the slider. It was just light tripods. And the 8 was calculated just to have in between 30 and 45 degree of incidence, in order to allow a good bottom and top automatic merging. With this setup, and especially with the light, we were in really optimal photogrammetric settings in terms of photographic parameters. Everything was fixed. And we were in minimum ISO with a really good aperture to have the best deep of field and the sweet and the maximum sharpness, and with really low shutter speed. So it was really good to have a fast digitization. We were shooting at in between 1 meter or something, and the GSD was 0.5 millimeter, which is more than enough that what we intended in terms of precision and resolution. We added a protected cover just to avoid all the tie points that could be problematic when we want to match the bottom and at least the 2 faces of the survey. And everything, as you can see, was prepared, and I will explain the scene preparation just after, with a pre-calibrated bracket with a coded target to define the origin, the axis, and the scale. We also added scale bar on each face, or almost each face, to enable that all the photogrammetric picture, at least seeing at the single picture, could be also used for documentary purposes. And of course, we use gray charts, and we use also 2 keyword subcodes that we put on the scene, and I will explain later on. So the modus operandi is really simple and efficient. We put an object on the scene on the first phase. We made a first loop. The first loop is quite simple. I just make a simple turn at 363 with a minimum overlap. And then I complete with some picture on each sides of the object. Then it was the complementary shot that was needed. It's quite eloquent on the picture there. I think, yes, I have a really a small making of to show you how it's done exactly. And then when we have done one phase, let's call it top, we just turn the object and reproduce the same acquisition protocol. And then when it's finished, we move to another item. And with this mean we were able to have all the acquisition done on one single object quite efficiently. Now I will show you how it was done on maybe it was the biggest object that we have. So the camera that you are seeing just around is not my camera, it's the camera because the French TV was turning a documentary. I want to show you this because, as you can see, they were using a really powerful light, and it was not affecting at all my acquisition because the flashlight that I was using is so powerful that even their constant illumination was not parasiting my own acquisition. It means that this protocol is really efficient in terms of colorimetric and to obtain a homogeneous collection, because you can work even maybe outside or in different contexts. As long as you use this setup, you can work in different kind of context. Now, if we go in lab, so the processing is a quite common photogrammetric processing. So we just import the face, the one face. We detect the marker in order to set everything up and to scale all the model. Then we do the matching on the first face. We import the second face. We match the second face, and then we register the phase 1 and the phase B. Together, we merge everything, we optimize the camera, and then we adjust the bounding box in order to once again avoid all the outlier that we can have on the scene, in order to have a clean, dense point cloud at the end. We can also filter it by confidence, and everything was done. So in this case with Metashape, but we also use we can also use open source software, because you will see for IOLI purposes we have to use micmac data. And we created a script in order to export all those the data set in order to make it directly compliant with IOLI frameworks. It means that you can export directly this data set and to import into IOLI. The result was quite good, because I think like 80% of the data set were generated almost fully automatically. In comparison, this was the scanner made by Mercurio, so our colleague, which created a startup dedicated in digitization services. And they also were involved in Notre-Dame. They were also digitizing some fragments, but the fragments that I worked on was colorized, was not at the same place, and they were not at this moment available, and it was complicated to send them on site. So that's why I was called to go there, and it was not the same purpose. But to compare more or less the mission, we have 3 days on site. I've captured up to 3,000 pictures, and I acquired 46 fragments digitized. So it's more or less 15 fragments per day, and it's actually half what the machine made with the same temporal range. Of course, the results are not comparable, because the intention and the objective is not the same at all. Our goal is to have a coarse digitization and a fast one, while with Mercurio scanner, the number of pictures is not the same. It's maybe it's 4 or 5 times more. Of course, the resolution and the resolution and the accuracy is way better with the scanner, but we are maybe a bit faster with this first method. I think it's the first approach in order to digitize a larger correction, and maybe afterwards send and use this scanner in order to complete an acquisition. Everything of this work, I mean the work of Mercurio and also including mine, is also devoted to be implemented into a 3D viewer that will be presented this afternoon by Marco Cagliari. So just to say that this acquisition, this experimental setup was really closely linked to other bricks that before, like archaeogrids and all the Notre-Dame ecosystem. The results there, we were quite convinced by this method. We created a quite homogeneous collection, which is reproducible. We can go there and maybe complete, because we discover a lot of fragments that was not on a good place or etc. It was quite versatile because I was able to digitize some elements between 1 meter to 10 centimeter range. It was quite fast, of course. It's low cost because it's just, I mean, basic photogrammetric instruments. Nothing, everything was more put on the method than on the equipment itself. It's really cost efficient because less picture, I mean, less time on site, less time processing, and less money because less computation. Now I was processing this with my laptop, and I don't need like a really computational server and a huge storage and etc. And it's quite robust because I just have some mistakes on 2-3 objects, and those mistakes were actually related because I'm not a machine, and I may fold the camera, I may have unsynchronized the flash, I have missing phase because we are not rotating the object in a constant way. So just human mistakes. And then what we are supposed to do with this? Maybe we don't know really the picture, but this is the laser scanning of the oculus. And Livio actually was working on the virtual anastylosis. So he was taking all the point cloud and the models that we were creating with this framework and trying to reassemble everything. All this work is linked with IOLI, with linked with NDAM. We are also working on the fact to provide the unprocessed raw for the documentary processes that was discussed by Olivier. And of course, we can implement or optimize a bit this workflow. We can think about a lot of valorization possibilities in terms of 3D printing serious game, virtual-based reconstruction, etc. But I will also want to add a little words about an experiment within the experiment. As I told you, I put on the site directly just next to the object a specific QR code. We were saying just before that semantics is the key, and in this context of Notre-Dame, as you can see just before, said Olivier and Sarah, metadata and all data provenance is really challenging. So I was thinking, I had the idea of integrating a QR code just inside the object, and this QR code is actually describing in a really efficient and simple way, not using a common standard, but using a structure inspired by ontological model, really simple structure actually, just describing who, when, where, what, how, which, and why. And if you are you have the capacity to encode this directly on your data set, you can fill the gap that all the metadata related to this source, and also the output and all the file that will be derived from this data set will be automatically enriched with this metadata. So since the beginning, you are integrating the metadata, and you are not obliged or constrained at any time of your project. For example, when you want to do a deposit on archaeogrid, you have to add the metadata, which is really important. With this method, where I'm working right now with Sarah, to integrate the QR code reader, or at least the file which is behind the JSON template, to automatically document the data acquisition since the early beginning. And this is even more interesting if we think that it's possible to have a modelization, a semantic modelization of this template. We can move toward web semantic friendly data. And I think it could be a breakthrough or game changing if we think that even in the first day that you are acquiring your data, you are directly collecting web semantic friendly. It means that your data on site is possibly already available for harvest or something like this. So in conclusion, this mission, all this setup and the workflow and this methodology was above our expectation. It was also, as you can see, a great pleasure to go on site with Livio, who was holding a camera and doing data acquisition maybe for a decade. And it was really interesting. We made a lot of discovery because when we were on the Barnum, we were thinking that, okay, maybe this object was also at this place, and it was really a great experience. The objective itself was totally filled. I mean, for the emergency documentation, everything works great. The method itself, from the beginning, from the data acquisition to the potential enrichment that we can do with those data, is really efficient. The setup is really lightweight, it's affordable and transportable, and it's optimal. Even if we can think of some possible adaptation, we've made it on a restrained data set, but it's totally doable to extend this. We can totally look forward to a zero-button, fully automated process, because if we put some instruction within the QR code, you can just put your SD card onto a laptop and everything will be done, because we know exactly how it is supposed to be done. And more importantly, we have maybe we feel an important gap concerning the metadata and the documentation and the data provenance, because as we can see just before, at least for this very short example, which is quite experimental, we have already 30K 3,000 pictures that are already pre-indexed and already integrated into Notre-Dame ecosystem. Thank you.